Computer Programming Essentials, Unit 6, Part 1. In the past, we've covered the sequence structure. As you may recall, every problem can be solved using a combination of three basic structures: sequence, selection, and iteration. We've already covered the sequence structure. That's one statement being executed right after another. This is the selection structure: decisions, if statements, how we make a decision in our code to do one thing or another. So in this unit, we're going to cover Chapter 5 in the textbook, and we're going to cover decision-making logic, how to make decisions with the if and if-else structures, how to use multiple statements in if and if-else clauses, nest if and if-else statements, use the and or operators, make accurate and efficient decisions, use the conditional and not operators, and assess operator precedence. What's going to happen first? When we're planning decision-making logic, it's really important that we think through how to solve a problem first before we try to write code for it. This is essential and really important for every programmer. Even the most simple problem will benefit from having a handwritten solution before the programmer starts to write code. There are two basic tools that we use for planning this decision-making logic, and one is pseudocode. I have to be honest, pseudocode's my absolute favorite because it's the easiest. Use a piece of paper and a pencil. I prefer yellow legal pads. And you plan the program's logic by writing plain English statements. What are you going to do first? What are you going to do next? You accomplish important steps in a given task and use everyday language, just plain English statements. You might think my favorite example of pseudocode is a recipe. That you might have a list of ingredients and then heat the pan on medium heat and melt 2 ounces of chocolate. Add a stick of butter, and then add 1 cup of sugar. So we're not saying exactly how to add the sugar or how to measure the sugar. We're saying to add the sugar, and we can fill in the blanks in our head because we're accustomed to cooking, for example. The same is true with pseudocode. You don't have to fill in all the steps, but as long as you just walk through it in your head logically, what's going to happen first, what's going to happen next. And that's important for pseudocode, one line representing one step. A flowchart models logic for a program as well, but it uses geometric shapes connected by arrows. Because a picture tells 1,000 words, many people prefer the flowchart approach because it's more descriptive and can more easily communicate an idea with someone else. There are certain shapes that we all agree on, and I'll show you those in a moment, for creating flowcharts. And I will expect you to learn these shapes, and they're coming up in just a second. The sequence structure is one statement after another unconditionally. Melt the butter, add the sugar, those things are happening regardless of some certain conditions, and that's an example of a sequence structure. Here is a flowchart representing a sequence structure. Directions for someone: go west on Algonquin Road, turn left on Roselle Road, enter the expressway heading east. It's one thing right after another. You might recall looking at something like this in Google when Google's giving you just directions. And this, by the way, is a flowchart. Here are the flowchart symbols that you will need to learn. The oval is the start and stop symbol, or the start and end symbol. One oval represents a start and one oval represents an end. In a flowchart, there should be exactly one start and one stop. Next, we connect our flowchart symbols with arrows. Notice that there's a little arrowhead representing the direction of flow. And these arrows should primarily flow from top down. We want to represent a top-down flow in our flowcharts. The parallelogram is the input-output symbol. You use that to represent input as well as to represent output. The rectangle represents processing. And finally, the diamond is the decision structure. There are 5 symbols there, and you will need to memorize each one of those 5. I encourage you to make flowcharts for these 5 symbols so that you remember what they're used for. You will be tested on them. The decision structure involves choosing an alternative course of action based on some value in the program. All computer decisions are yes or no decisions. They are Boolean decisions. The answer is true or false. If I ask, how old are you? That is not a computer decision. That's not a yes-no decision. I have to say, Are you 16? Because that's going to be a yes or no answer. So think about when you're playing the game 20 questions and all the answers are yes or no. Those are the types of decisions that a computer can make. Is the answer yes or no? It can't deal with ranges of values unless it's forming that in a yes or no decision. Here's an example of a flowchart that includes a decision. Go west on Algonquin Road. Turn left on Roselle Road. Is the expressway backed up? That can be a yes or no answer. If it's no, we go one way. If it's yes, we go the other way. Notice how those flow lines are labeled. We've labeled the direction we go if it's false. We label the direction we go if it's true. It doesn't matter if you use the words true or false or yes or no, but they need to be labeled. And then notice how they come back together. After you do the no path or after you do the yes path, they both come together to proceed to 688 Arlington Heights Road. The if statement is the simplest statement to make a decision. It's a Boolean expression within parentheses, and there are no spaces between the keyword if and the opening parentheses. You can put a space there syntactically. Java doesn't care, but typically programmers don't. The execution always continues to the next independent statement. So regardless of whether or not the if is true or false, after it's done, it will continue flowing in a sequential structure. To test for equivalency, we use the relational operator equals equals, not the single equal sign. The single equal sign is the assignment operator. We need two equal signs to represent testing for equivalency. Here's an example of what this would look like. If score equals 10, so if the quiz score is 10, then we're going to print out the score is perfect. Otherwise, we're going to keep going. So look at how it's represented in a flow chart. Quiz score equals 10. If that's false, we just keep going. If it's true, we output the score is perfect. Notice the words that we've put in those symbols, they are not Java code, but they represent what's happening in the Java code. So it's English-like statements. It doesn't have to be perfect Java code inside your flowchart symbols.